All right, today we're going to look at a word problem, not just any word problem, a word problem that we are going to turn into an equation to solve, okay? So what we have here is a word problem with a bunch of numbers and, of course, words, and we need to solve for a variable. Just like a regular equation, this is our goal in this problem, to set up and solve this. So pay very close attention to how we are setting it up, with the steps that we are following, and we should have no issues at all. Mr. Gonzalez has only $42.50 to spend at a clothing store. He wants to buy a shirt that costs $29 including tax, and some bracelets that cost $4.50 each, including tax. Write an equation to determine X, the maximum number of bracelets Mr. Gonzalez could buy. Solve the equation to determine the number of bracelets Mr. Gonzalez could buy. Awesome. Now, whenever I start a problem, if I am capable of doing this, I like to go ahead and start by circling my numbers. Make sure that each number I have here is circled, so I make sure to include it into my problem, unless, of course, we see distractors. Now, it's also important to figure out actually my first step, the very first thing I want to do in my problem before I do anything else, is to find out what we are solving for. Make sure we understand, what are we really solving for in this problem? What is my goal in this problem right here? And in this case, we are trying to write an equation to determine X, the maximum number of bracelets Mr. Gonzalez could buy. So I know, based on this, that I know exactly what my variable is equal to. I'm using the variable X, which is the maximum number of bracelets. And we're going to come back to this as soon as we're done with our problem to make sure our answer makes sense. We don't want to have half of a bracelet or 0.3 of a bracelet or any sort of fraction here. We want to make sure our answer represents full number of bracelets here. Now, my step 2, and I will keep referring back to this, is to find our total. Okay, the total in my equation usually, but not always, is my largest number. It is what we are going to get after doing all of our operations. Now, in this problem right here, Mr. Gonzalez has only $42.50 to spend at a clothing store. This sounds very much like the total that the largest total he could receive if he was going to be buying stuff. Okay, he of course, could spend less than that, but this is what we are going to use as our total. So I am going to start this problem off by putting that number on the right side of my equation, and for right now I'm going to leave that number alone. I don't want to be adding anything to it, or subtracting, or multiplying, or dividing, or even including any variables over there. That represents the total. Every other operation I'm going to use should be on the left side of this equation. Step 3. Find out which number relates to my variable. Okay. In this problem here, we do have a couple more numbers here. We have the numbers 29, and we have the number $4.50. Now, oftentimes when setting up an equation, one of these numbers will relate directly to what I'm trying to solve for. In this case, X, which is the maximum number of bracelets. So it is going to require a little bit of reading what these numbers actually represent. This first number right here, this 29 that I have not included yet, is the cost of a shirt. That has nothing to do with X, the maximum number of bracelets, so I'm going to ignore that for right now. And we also have this $4.50, which it says some bracelets that cost $4.50 each. Perfect. Awesome. This number directly relates to my x, and actually even has an important word here, each, which means every single one of those bracelets is going to be $4.50. So this is $4.50 for one, another $4.50 for two, and I can keep adding and adding and adding until I add X number of bracelets, or we could just multiply. $4.50 times X. Now I don't need to put a multiplication sign there. These numbers, a number next to a variable automatically indicates that it is multiplication. So I can leave my $4.50x just like that. Also a reminder, I do not need to include dollar signs in my equation. Equations are specifically meant for numbers, variables, and operations. We have my fourth step here. Fourth step, use all other numbers as necessary. So we are going to take this problem. We are going to see, look, we have a 29 here we have not included. Now let's think about this. This $42.50 is going to represent the total in this problem right here, which means after adding up everything Mr. Gonzalez is going to buy. So my last step here is going to be to add on that $29 shirt that he wants to buy as well, because adding up all of his items is going to give him the total amount of money that he can spend. And there is my equation. Now I also need to solve this equation. So if you've seen my other video on how to solve it, that we are following along with the same steps. My goal is going to be to start by drawing a line going down from the equal sign. Okay. My suggestion if you are trying to solve any equation is, of course, to make sure that you are solving it on a separate sheet of paper. Do not try to just solve this by typing numbers in your calculator. If you mess up, you're going to have to go all the way back and start over from the beginning. We definitely don't want that. Now to solve this, I am going to do the opposite of whatever operation I see on this left side. Now I technically have two operations here. I have a multiplication and I have an addition. Now the easier of the two to get rid of is the addition. If I try to get rid of the multiplication, it's going to require a lot of division, which is going to possibly give us some unwanted fractions, even fractions with decimals inside them. So let's deal with this plus 29 and solve with the opposite. The opposite of plus 29 is minus 29. And of course, if I am subtracting from one side and this is supposed to be equal, we also need to subtract from the other side as well. Minus 29 from the left, minus 29 from the right. Now what happens when I subtract these numbers? This 450x, nothing happened to it. It's still there. It still is part of my problem. The 29 and 29, well, they subtracted each other. They are now gone. They are removed from the problem because that's like adding 0 here. Now on the right side of my problem, we actually are going to need to do some math. So make sure you have your calculator ready, or you can solve this without a calculator. $42.50 minus 29 is going to change this side over here to 13.5. If you want to add on this 0 here, you can. But this is an equation, so we don't need it at this point. We can leave it as 13.5, and it will not change it. But remember, our answer here that we are actually solving for x is not going to be having any decimals or fractions. Told you we would come back to this. We are solving for the actual number of bracelets. I feel like half of a bracelet would probably be broken. We wouldn't be able to be used. So let's not worry about that until we're done with our problem. Now my last step here is to get rid of this $4.50 that's next to my variable. My goal in every equation is to isolate the variable, get it on its own side by itself. We are going to do the opposite of multiplication, which is division. Divide by $4.50. Divide by $4.50. And this 450 divided by 450, that's just 1. That's going to disappear and leave me with just x right here on this side. X all by itself means I now have my answer. And I have to do the division here, of course. $13.5 divided by 4.50 is exactly 3. And so there is no need to change this. There is no need to round or anything like that. We have created an equation. We have solved our equation. And my last step is always to make sure this is a reasonable answer to this problem. Solve the equation to determine the number of bracelets Mr. Gonzalez could buy. He could buy 3 bracelets. And that is it.